Good morning to all. Today we are discuss about chapter 2 external causes. Lightning. An electrical discharge between cloud and earth, between clouds or between the charge centers of the same cloud is known as lightning. Lightning is a huge spark and it takes place when clouds are charged to such a high potential with respect to earth or neighboring cloud. Lightning is an unavoidable event that affects power systems through several mechanisms. The obvious interaction is a flash on the power system, but other coupling mechanism can also produce overvoltage. The next possible lightning stroke, direct flash. Lightning current flows through the earthing impedance, resulting in overvoltages. The effective impedance of the lightning channel is a few seconds 1000 ohms. Lightning current can be considered an ideal current source. For example, the diagram will be represented for line propagation surge. So the direct lightning affected by the transmission line. The next one, the surge from direct flash on building. So in the lightning effect, it will be direct to the lightning effect direct to the building. The next one, rear flash. The voltage is induced in surge, which in turn produce surge currents. That means rear flash means nearby the transmission line, the lightning effect will be affected. So as well as the reactance values are improved in the transmission line. The next one, earth coupling and induced surges. For earth coupled in the home and the rear flash affected in the nearby the home. The next one, far flash. For a given flash, the severity of transient overvoltage appearing at the end user depends upon first one, coupling path such a distance and nature of the system between the point of flash and the end user facility. Second one, earthing practice and earth connection impedance and branching out of the distribution system. Here the diagram will be represented for the line induced surge. That means for flash it will be create the minimum value of change in reactance level in the conductor in between the next one, induced line induced surge. That means for flash it will be affected for the some magnetic reactance level in the indoor systems. Classification of lightning surge. Current surges due to direct flash to overhead line, including back flashover events. Induced transient transmits over voltages on overhead lines due to flash at some distance and resulting surges current. Voltages caused by resistive, inductive and capacitive coupling for system carrying lightning currents and the resulting surge currents. Next one, direct flash to overhead lines. The effective impedance of the lightning channel is high and the lightning current can be considered as an ideal current source. The resulting over voltages are therefore determined by the effective impedance that is seen by the lightning current. For flash to an overhead line conductor, the impedance in the first moment is determined by the characteristic impedance. That means surge impedance of the line. Given the typical value of characteristic impedance ranging from 10 ohms to 400 ohms. A very high over voltages occurs that causes flashover to earth long before the service entrance of a building becomes involved. Therefore, the lightning surges appearing at a service entrance while reflecting the severity of the lightning stroke and its distance is not resemble to the actual lightning current. The next one, induced transient overvoltages on overhead line. Due to changes in electromagnetic field caused by the lightning flash, surges are induced in overhead lines and also considerable distance from the flash. These voltages are same for all conductors because the phase separation is small compared to the distance to the flash. However, induced voltage does not necessarily appear at the service entrance. The high levels will be produced flashover to the earth or operation of surge resistor. That means surge arrestor. So that the surge appearing at the service entrance are more likely to be a range of few kilovolt. As noted before, the surges involve sufficient overvoltages but reality small current levels in constraints with the surges resulting the strikes when the current source aspect of the phenomenon result in current surges that reflect the dispersion of the original stroke current among the paths offered to this earth seeking current. The next one, transient overvoltages caused by coupling from other system. A lightning flash to earth or to a part of a system normally at ground potential can result in an earth potential of high value of the point or of the stroke. This phenomena will cause overvoltages in electrical system using the point of earth as a reference of their earthing system. The diagram will be represented for the transient overvoltage caused by the coupling from other system. That means in the outdoor system to continue the content. The potential rise of earthing system is determined by the lightning current and the effective earthing impedance. The potential of earth electrodes is determined by the local impedance 10 ohm. The high voltages is produced between the earthing system and the electrical installation inside the building leads to installation breakdown. Therefore, the current impulse can flow into various systems, mainly determined by their earth impedance. In this way, overvoltages are produced in the power supply system and the other connected services such as telecommunication, data and signaling system, etc. At the consequences, the overvoltages are transferred to the other building, structures and installation. For instances, all power installation are published are supplied by from the same distribution transformer affected by the lightning stroke due to high electromagnetic field caused by lightning current, inductive and capacitive coupling to electrical system that are closed. Lightning can also cause over the concern, especially electromagnetic and data system, causing failures or malfunction. Thank you.